One of the bugs that we can easily observe is that the read in simulation data function is reading a file and it's reading through the lines, and it's now grabbing the characters on the first character of the line and then the third character and everything ahead of that particular line. What's going to happen if we have two digits in arrival time, let's say? It's probably going to throw an error, which we will look at right now. And there you have it. The exception is here. If you can continue, invalid literal for integer with base 10. So, so colon 25 slash n is on the character third character and ahead. So third character is this, and everything ahead is 25, and the next line slash n. So it's trying to convert this into an integer and it's failing. So that's exactly what this error is. So how do we fail proof this one? One easy method would be to create a variable, this file row, and use the data string variable data string as an object and split it using the colon. And what's going to happen is this file row is going to become a list of the first item in the list being the value on the left side and the second item being value on the right side. So if we pass this instead of the data string on and take the first item in the list and the second item in the list, this should resolve this particular issue that we see. Let's run this one, and there you had it. The same output is coming up over here. Now suppose the simulation data.txt file doesn't exist. What's going to happen? Let's try to say that it's a non-existing one, just by changing the file name. Let's try to see what's going to happen. As you can see, the error file not found has been thrown, no such file or directory. So how do we handle this? So there are different ways which we could do that. One of my recommended approach is this, where we have a try catch block, try except another except. So in this, what's going to happen is we are adding a parameter to be passed, and the default of it's going to be done. So just in case this hasn't updated file path hasn't been passed, it's going to be treated as none. In the try catch block, what's going to happen is it's going to check if updated file path is provided. If it is, then it's going to pick that up. If not, it's going to use the default one, doc simulation data.txt, and it's going to try to open that file path, and it's going to see if that particular file exists. If it does, then great, it's going to perform the operation and print out the data as needed and return the data of all the customers from this particular file. In case the file is not found, what we are doing is we are writing an error to the user. The file is not found at the path, providing the path name to the customer and or to the user of this particular script, and telling them please update your file path. An opportunity for them to update the file path, and then re-triggering read in simulation data using that particular file path, otherwise none. So essentially what we are doing is we've added an generic except block to catch any other potential exceptions and handle them appropriately. I've also added a check to ensure that the function returns none if no updated file path is provided, to avoid potential issues with infinite recursion. And let's have a look at how this works. And when I click on no, it's first initially what it's going to do, it's going to check the default location doc/simulation.txt, and that's the error that we are getting. The file is not found on this particular path, please update your file path. So some random path file dot text, that's not going to be available. It's going to keep on giving me that error until I actually give the right path simulation data.text, and there you have it. It works fine now. Another improvement that I can see that we've already discussed is the number of tills and stats data which is passed but not used. So we can just delete this and not pass this information at all back. So that's already available, so the code should just use that. So buyers arrive, number of tills and stats. We don't need to create these values from there because that information should already be there. Now trying to run this, and let's see what's going to happen. Simulation data.text, and as you can see, it still works. Another optimization that we can do is the buyer arrives function. It just prints a statement and then calls another function and returns the values. So instead of having two functions and overutilizing resources, memories on the script, and making too many functions, what I would suggest is just directly do this inside buyer arrives. So we have apologies, just deleting that, and let's try to run this once again. Buyer arrives, a condensed version of it, and as you can see, we are getting the same results. Another recommendation from my side is to use PEP8 style guide for Python code. What exactly is the PEP8 style guide? It's a Python enhancement proposal that provides guidelines for writing Python code in a consistent and readable manner. It covers various aspects of coding style, including naming conventions, indentations, spacing, comments, and more. PEP8 essentially improves code readability and maintainability, especially when we are in big organizations and in collaborative projects where multiple people and developers are involved. It ensures that the code quality is of optimal standard and everybody is able to read it. Especially in this particular situation, the code that we've got over here, it's not really very easy to read. There is too much happening over here, and there are too many parameters moving around, and we are printing out tables by using spaces which can easily break. So there are quite a lot of things which are not following coding standards and practices. So what I would recommend is ensure that we follow PEP8 standards. A few of the standard practices within that is indentations, which recommends using 4 spaces per indentation level. Avoid using tabs for indentation. There's a line length limit of 79 characters. Blank lines, use blank lines to separate functions, classes, and logical sections of code to improve readability. Imports, there's a bit of information about imports and how we should be doing that, a bit on white spaces. Naming conventions, variables, functions, and methods should be in lower cases with words separated by underscores, such as this snake case. Constants can be all caps, that's fine. Class name should use the cap words convention, also known as the camel case. So first alphabet capital, all the words joined together with each word's initial alphabet capital. Private variables and functions should start with a single underscore. So these are really very good standards. If at all we wanted to upgrade this particular function, this particular script a little further, then we should ensure that we follow the PEP8 standards. Comment should be available with a single hash followed by a space. Doc strings, functions and method arguments, white spaces and expressions. So what I've done is I've gone a little step ahead further, and I've created a PEP8 code review pre-commit YAML. So this is the configuration for pre-commit, which is one of an option when we are using Git. As you can see, the hooks are available, a prettier hook, the black hook is available, which is again another code formatter. There are various different ones which are available, plus Flake 8, which essentially follows the PEP 8 style guide. So if at all in a real world scenario when multiple developers are coding and they are going to commit a code, when they commit a code, this particular hook is going to be triggered, and it's going to ensure that uh, all the style guides and are followed. If not, it's going to throw an error, and the developer will have to ensure that they fix that error first before they can actually commit the code. This ensures good quality code always goes onto the production websites. Um, the configuration is here, and what I've done is I've also updated the simulation.py with object-oriented programming version. And as you can see over here, I've just left the queue node as is. I've created a new class, and I'm calling that a final stats, and I'm creating integers over here with max queue length, time wait, type total wait, queue occurrences, no wait. And I'm creating the stats initially, instantiating it with zeros from a range of 7, instead of the previous version or the original version of the code where it was creating the array of 10 zeros. Instead of this, improved version would be in this kind of a manner, where we are just ensuring that since we just need 7, just use those. And in the final stats class, I've also got an output stats method, and this essentially at the end is going to be called, and it's going to print out all the information, and it's just going to use self dot and this in terms of object oriented programming, it's just going to be using the parameters within its reach and availability. I've got rid of the global variables and set up passed in the constants within the class, and I'm calling that class a simulation. Within it, I've created an init function. Now you can see the interesting method and approach that I've gone with. So I'm creating tills, buyer queue, simulation time, number of tills, all of them are being set over here, and the data value is reset within this init function itself. As you can see, I am resetting it to the max of time plus 1 over here, and creating that list exactly what the original code was doing. And I am also triggering the change settings function directly over here in the init function. So what's going to happen whenever this simulation sim.py is going to be triggered, the init function is going to be triggered, and instantly change settings is going to be triggered. In the original version, what's happening is that the reset data structure happens over here, and then it passes the variables. Then change settings happens here, passes the variables. The read simulation data passes the variables. So instead of passing variables everywhere all around the place, what I'm doing is just calling this particular function. That's pretty much it, and the variables are going to be stored within the object and going to be read from there. Obtain data, again a same function which is automatic, which has to be triggered, so I'm just putting it in the init function. Output heading, again it has to happen, just put it over there, no point keeping it separate. And then final stats is going to be triggered as well. Now change stash function, just for testing purpose, I've commented this out. You can uncomment it and try to test it yourself. So it just does pretty much exactly what it already does, and it just returns self dot simulation time and self dot number of tills, which is a parameter within this particular class. Read and simulation data, a little bit more optimized, as you can see, and read. I haven't added the try crash block over here, but do feel free to do so if you wanted to take it a little bit step ahead from here. I'm adding comments. PEP 8 doesn't allow multiple hashes, but just for readability of the comments and the blocks and making them stand out, I'm adding really very huge comments over here just for you guys to understand. Uh, so there are functions which are associated for buyers. The buyer arrives, as you can see, I have condensed it into one. Services, it can be optimized, as you can see, uh, self.find free till, pretty much the same function. It finds a till and runs the rest of the logic. Serve buyer, again a buyer perspective function. Calculate serve time, similar over here. Increment wait time, nothing much to be discussed over here. All the rest of them are quite similar. All they're doing is picking up values which are already available within the class. The stats, just for understanding purpose, I'm just adding the stats over here, and you can see self.stats.total weight plus buyers and all the information over here. I've kept the output blocks separate, again a little bit more easier to understand. So this is output heading, and it's this one is output till and queue states or status, to be honest. So as simple as this, keeping it separate ensures that we all understand which part of the code is doing an output, which part of the code is associated with stats, which part of the code is associated with services. This one over here is the actual simulator, Q simulator, and I'm using the PEP 8 kind of standards with words separated, small, all lower cases separated with an underscore. And first the simulation object is instantiated, and from the simulation object the Q simulator is triggered. Q simulator then goes ahead and it does exactly what we've already seen in the original version. Serves until close of simulation, serves the remaining customers, completes serves the ones on the tills, and end of it, it just outputs the stats. As you can see over here, it's so convenient not to pass too many variables around, and it in a sequence just ensures that one or the other function is triggered, and that's pretty much it. So for example, buyer arrives, I'm not passing any variables because all of those variables are already available within the class and are utilized above in it. Similarly, serving, no parameters passed at all of those parameters are already available, so I am just using already available parameters using using self dot functions everywhere, and updating stats, which is stats itself is the final stats class object, and updating the parameters accordingly. So do feel free to download this and try to run it on your end and try to compare the output of both the files. The way you can actually output the information which is on the console into a file is quite simple. All you need to do is Python simulation.py is actually going to trigger the function, and everything is on the console, as you can see. If you want it in a file, just add this bracket over here and output.text, enter, no, enter, and over here output.text, you can see the entire content of that particular file has come out over here. For a demonstration purpose, I've just opened up my version of the file, sim.py. This is the object-oriented version with the final stats and the simulation class, and when I run it, surely enough, it pretty much gives the exact same output with all the time units and everything, exactly as the original version does. And like I mentioned, if you wanted to compare both, you can just do Python sim.py or simulation.py, bracket open, and output.text. I've done it in v2.text already, and I am comparing both of these outputs. What I'm doing is I'm just comparing both of these files. Just select both of them together, v1 which is from the original branch, original code, and v2 is from my optimized version, and when I compare it, where on my version I have commented out the section which asks for the settings, and it highlights that this particular line is different. All the rest of the lines are exactly the same, so the output is completely identical. And when we go to the bottom, I have commented out press enter to finish as well, and when I compare, both of them are exactly the same as well. So you can rest assured that this code is working exactly how it intends to. However, feel free to uh, fiddle with it, break as much as you want, or try to introduce or optimize as much as you want. Hope all of that information helps.